Hello, welcome to my YouTube channel, Math World. Okay, so this is my first video and I'm going to start by looking at questions in paper 2. We'll start with matrices. So we'll look at questions from 2016 up to 2020. So under matrices, in 2016 paper 2 matrices came under question 1a. And the question says, given that matrix Q equals 3, negative 2x, and 4, find the value of x given that the determinant of Q is 2. Then question 2 says, find the inverse of Q. So we are given matrix Q with elements 3, negative 2, x, and 4. And we're also given the determinant as 2. Okay, so for us to find the value of x, since we are given the determinant, we're going to use the formula for finding the determinant. And the formula for finding the determinant is of a given matrix is determinant equals, if we have matrix A with A, B, C, and D as elements, then determinant of A will be equal to A times D minus B times C. So that's the formula. So bringing this to our question, we're going to say determinant equals 3 is A, 4 is D, negative 2 is B, and x is C. So we'll say 3 times 4 minus negative 2 times x, like that. So we've simply multiplied the elements in the major diagonal and also the elements in the minor diagonal. When you subtract the product of this from the product of that, then you'll get your determinant. Okay, so determinant is given. We substitute that with 2 equals 2 times 4 is 12, then minus negative 2 times x is negative 2x. Okay, so looking at this question, we have equations and integers coming in. So we have 2 equals 12, negative times negative will give us positive. We have plus 2x. Okay, so you need to understand integers, otherwise you have problems solving such questions. So this is an equation. We need to find the value of x. So the first thing to do here is to collect the like terms. Okay, or first move everything to the left side, since we need the variable to be on the left side. So I can move 12 plus 2x then equals 2. I haven't changed the signs because I've moved everything. If I moved the terms one by one, then I was going to change the signs. Okay, then here we can now collect like terms, or simply introduce what we call the additive inverse. By additive inverse, I mean you look at the number you have here, then get a number that can give you a 0 when you add that number to it. Okay, so the additive inverse of 12 is negative 12. So add negative 12 both sides. We're going to have 12 plus 2x plus negative 12 equals 2 plus negative 12. So 12 and negative 12 will give you a 0, leaving us with 2x only on the left side. Then equals, we have 2 negative, positive times negative will give us a negative, so we'll have minus 12. Okay, so we have 2x equals 2 minus 12 will give us negative 10. Then for us to remain with coefficient 1, we need to divide both sides by 2. So we'll have 2x divided by 2 equals negative 10 divided by 2. We are dividing by this coefficient so that when it cancels, it gives us with a coefficient 1, which is just x. Then equals negative 10 divided by 2 will give us negative 5. So the value of x in this matrix is -5. So matrix Q is 3, -2, -5, and 4. So we are done with question 1. Then question 2 requires us to find the inverse of Q. So the inverse of Q is found by dividing 1 by the determinant of Q, then multiply by the adjoint of Q. That's the formula for finding the inverse. Okay, so we already know how to find the determinant. Then we have this new something new there. Okay, so to substitute, we have 1 determinant of Q is given, which is 2, so it will simply be 1/2, then times the adjoint is simply you bring the matrix you are dealing with. In case the matrix we are dealing with is this one. Okay, so to find this is Q, to find the adjoint of Q, you simply swap these elements, then change the signs of these. So swap the elements in the major diagonal or leading diagonal, then change the signs of the elements in the minor diagonal, or simply multiply -1 by the elements in the minor diagonal. So we're going to have 4 where 3 is, then 3 where 4 was. Then this will change the signs. -1 times -2 will give us +2. -1 times -5 will give us +5. So this is our adjoint and we have to bring it here. So we have 4, 2, 5, and 3. So multiplying half by those elements, we'll have half times 4 giving us 4/2, then 2/2, 5/2, 3/2. These figures can be reduced. 2 can go into 4 2 times, 2 can go into 2 1 time, then 2 can go into 5 2 times, remainder 1/2, into 3 it's 1, remainder 1/2. So this is the inverse. Okay, moving on to 2017 paper 2. The question under matrix came on question 1A again. Then the question says, given that matrix M equals 3, -2, 5,